it should be AI. I hope this is AI from Python program. This is basic AI with Python program. For the class, we have two sections. For me, I will is from this week until the week 9. That's week 9. So 19 January 2024 for next year. For next year, we have only one month and a half. Just happy new year. Right, okay. But for chemical engineering, you can start with me from the first week until week 9, like week 10, 11, and 12. If you would like to study AI, you can sit in this class. If you don't like to sit in, probably you finish the class at week 9 for your class. But for material engineering, you must start the class. You have to study with Ajahn Nantawut after that, got your class. That's right. Okay. For this part, we talk about the statistics applied for the data analysis and also the technique for design of experiment. So for this case, it's not only for the experiment. The Zoom ได้ยินอาจารย์ไหมถ้าอาจารย์ไม่ได้ยินได้ขออาจารย์ใช้ไมค์ได้ยินไหมโอเคพอไม่ค่อยชัดFor this, the first week, you talk about the property of the data and also the experiment, how to design the equipment that your laboratory. And most of it we apply the program for data analysis as Minitab. Also, as I talk to you, we have the program license in digital 12 ก็คือห้อง digital 12นะครับถ้าห้องหน้าเราไปก่อนใช้ได้นะครับแล้วก็ I will maybe like point you to demonstrate how to use the Minitab. I think you can study by yourself. And also in the PowerPoint side, I show you step by step in PowerPoint already how to use the Minitab for experimental design for data analysis for the step. You can follow the step by step in my PowerPoint for this. And also we apply Excel. We have two programs, Excel and Minitab. The commonly used is many programs for data analysis. Excel we also, but it's limited. For example, we would like to design the ANOVA analysis, but Excel is limited only 2 parameters. But if you use Minitab, it's more than 2. You can do that. Because in your experiment, we would like to study effect of pH, effect of the length, effect of temperature, effect of pressure. So it's many parameters. But Excel we only 2 factors. But if you use the Minitab, we can study more than 2 factors, for example. Right. Okay. And but for today, I will introduce you about the equipment design for simple, how to use the equipment. The sensor, what is sensor? What is actuator? Like how to calibrate the sensor. Your sensor, your equipment, accurate, precision. What is accurate? What is precision? What is robustness? You have to know about this. For that, and how to represent your data when you measure your data in the lab or in the program or in simulation. You have some value, the mean, and you report in the paper. You can find that when you read the paper, the report aside the mean plus and minus error. How to calculate that error. But for easy, you use the standard deviation. That's it, the estimation, not correctly based on statistics. But then we have the technique to calculate the standard deviation based on statistics, based on data analysis. That's not for that. Okay, if you use the sigma directly, that means your data should be normal. That's right, the data should be normal and you have the data is enough. That's right, big data enough. If your data is not big enough, how to show the deviation? Right. The technique I will talk to you for this. And after that, we talk about the statistics by accuracy test. continuous variable, that's right, what is normal distribution, and also the point estimation for that. And after that, we talk about the linear and non-linear. Usually, when we study in vector epistemiology, we focus on linear linearization. But in this part, we talk to non-linear and multiple linear and non-linear. That's right. Okay, for this. And then we will focus on experimental design by factorial design. Factorial mean factor. It comes from factor. We design based on factor. If you take your material or if you do the composite material, you mix it. We have 3 components mixed together. But for this case, we call mixture design. We have the technique for what is the best mixture. We apply the mixture design. And also, if you would like to study the effect, which effect for the strength for the atmospheric force, for example, the pressure, temperature, pH, component, percent, each component is concentration. So how to study that. For that, we can apply the factorial design. Factorial design, we have 2 factorial, 3 factorial. 2 factorial means 2 levels, low and high. That's right. And also you can modify from low and high. You can modify center. That's like for example, you study the low temperature and high temperature. And also you can modify to center. That means you have low and high and middle. And also you can modify center by axial, low, high, middle, and lower than minimum, higher than. For that, you have the technique. Like how, if you would like to study only the limit temperature 10 to 40, 10 to 40, sometimes okay, 10, 15, 20, 25, 30, 35, and 40, okay, 7 levels. But sometimes if you study this part, okay, we have only 3 levels is enough, or 4 levels is enough, not necessarily to 7 levels. That's fine. Because it saves your money, because it reduces your number of experiments. If you apply the statistics and the experimental design, it may be helpful to design the experiment. That's right. With parameters, you have to start. You have many parameters. That's right. But if you apply statistics or DOE design experiment, you can say, okay, this parameter is not necessary, not important. That's right. You can do the statistics to decide why this parameter is important or not for that thing. Okay, we talk to you in this class. And the last 3, as I would you introduce, I think introduce not the dude, introduce you about the AI. Yes, AI. I think is the Python program. And also we have some presentation in the paper. We give you some paper. But we plan to you choose some at least 2 papers. You find a paper that related to your work or related to your thesis, and you submit to me. I will check okay. I will assign only 1 paper for presentation at the end of the class. That's I did about 15 score, quite high score. This is I try to review some paper, try to understand. You read the paper and extract what you got from the paper. That's right, and then present. We have at least 3 instructors. Ajahn Vimola and Ajahn Nandawood will sit in the class and evaluate your presentation. And also in chemical engineering, may only for evaluate your presentation also. You have some present the paper. You say the paper that related to your work and related to this class. Okay, we have to complete the paper related to this class and also related to your research. Right? ก็คือ paper ต้องเกี่ยวข้องกับงานวิจัยแต่ต้องเป็นการประยุกต์ใช้วิชานี้ใน paper นั้น Okay, for the final. Okay, and also during for task evaluation, we have like data analysis. Okay, we have 3 that side. We have paper-based exam. Right? We have the paper with the only one at the end of the class. And also we assign your homework or assignment. And also you have to present homework. or 1 pound per student. I will random for okay if I give you assignment this day for next week, we will choose at least 1 or 2 students to present the homework assignment. This is the only one time because we have about 15 students, assign 15 students, okay, 2 students per week is enough for that. At least 2 questions for assignment. And then we present in front of the class, describe about the homework, how to represent, how to do them. This is 50% submission part presentation. And also we have oral exam also, right? Okay, we're calling oral exam, but I'm not sure that we have enough time, but I will try to take this. Right, yes. Oral exam is okay to take. I ask your answer, not asking. I have some questions to ask you about the concept, not calculation. Oral exam is about concept, how to. That's right. The question is how to do this. I understand this, would you just try this? If you have to calculate, you only suggest the technique. That's how to calculate the technique to calculate. Let's see the other example for that. And Ajahn Nantawut only assignment, I think. That's why 20%. Okay, this is all of the tutorial about the class. So what about the evaluation? No. For chemology only. Yes. No. No, for chemology, this is for material class, not chemology. Yes, I will send you again. Okay. It's maybe 50% paper-based exam, right? 50%. And 20% oral exam, it's maybe 15% assignment and 15% paper. Okay? You don't worry, my Excel is open. Take home, right? And usually we have to try our Excel in class about 3 hours and take home about 50%. In class 50% and take home 50% for paper-based exam. Because in class we some the same question, but take home is maybe different question for each student. But you can do with the group, don't worry about that. You can ask your friend, we can do together, I don't worry about that. That's fine. But take home, because you can do together. This is the take home that I would like to do not only by yourself, you can ask your friend, you can ask AI, don't worry about it. Because it's the real world. It's the real world. Do you have any question for the class? Okay, if you have no question, I start the class for the first week. I introduce you about the equipment design for that skill. ทางบ้านเห็นใช่ไหมอาจารย์แชร์เป็นแบบสกรีนแชร์อยู่แล้วเนาะ
เห็นค่ะอาจารย์
ต้องมีคนมาช่วยอาจารย์สอนอันนั้นอาจารย์สอนคนเดียวจะไม่ได้เลยต้องมีคนนำเสนอต้องเป็น Okay. I understand my English คือเมื่อใจว่านานๆก็ภาษาอังกฤษจะระดับออกราวหน่อยเนาะว่ากันนะครับออกมันนอกหน่อยนะครับ I'm not a native speaker I to understand I think all of us is not a native speaker something this week wrong grammar is calling grammar don't want to call it okay look at for the first topic I would like to ask you why we have to do the experiment we have why we have to do the experiment for this case is we have at least 5 questions why I answer the first one because if you have the owner of the company you would like to create a new product this is the first lesson you would like to create a new product you have to do the experiment the experiment may be from the experiment from the simulation to get the experiment in this case you can apply the technique for experiment for simulation or for combined simulation and experiment because the product we have to do the product we have to produce a new product that this product is more efficient or cheaper than the previous product that's like this means the previous product that's like previous predecessor this means the old one the previous one by the new product you have to develop the experiment because you would like to get to build a new product and the second if you would like to produce a new product that means you have to find process how to produce this product how to produce this product this process you have to develop process and the process to develop your product is many ways you have to choose the way that is economic you would like to produce ethanol for example you would like to produce ethanol you can produce from chemical you can produce from biomass it's many ways and also from chemical is also we have many chemical reactions that's right in bio process it also is many process which process you would like to do in your product this is also you have to do the experiment you have to check which process is possible and also it save your money for that case this is why you have to do the experiment and the second one after you get it you have to find optimize process optimization we have to optimize raw material minimum not maximum when you are engineer I have to check the cost it's the minimum raw material minimum energy minimum labor input that's right now we use the technology the automatic robotic instead of labor that's right for that to save the money and also we have to maximize product quality you minimize cost minimize labor minimize raw material but you need to maximize product quality it's very important product quality that's right maximize product quality and also product quality is we have many quality based on engineer decision but sometimes quality based on customer it's very important quality based on customer that means the spec of your product it depends on customer what the customer needs that's right what the customer needs you would like to produce some product you would like to release the product in the market you have to set the market what is your customer you have to check and then you have the spec of your customer is also very important this quality also need or meet the qualify of product and also need the engineering design that's right engineering design for that and then after you get the product you get the process you choose the optimum process and then checking. That's right. You have to check when you do the process. When you produce your product, the QC is very important. That's right. QC, that means process inspection. You would like to produce some material, that's right, a new material, composite material. This is a really good property. Right. This material is also good for the solid fuel in the space, for example, in the airplane. It's really good. Right. For that case, have to check this is qualified or not. That's right. This is according to the spec or not. And also when you produce your product, when you are working QC, you have to check the QC. What is the area you accept? In the real world, when you produce about one piece of your product, it's maybe some product that not meet the spec. This is out of the spec. But sometimes you buy computer, you buy notebook, you buy mobile phone, something. It's good luck before you get the off spec. It's possible. It's possible because the QC will pay. In your company, okay, we accept 20% error. It's possible. When you buy the iPad new one, oh, is this out of spec? It's not good. It's possible. That's right. But you sometimes the guarantee from the shop, right? When you get the guarantee from the shop, because there are some errors. This QC, not 100% perfect. No, this is the real world. It's not 100% perfect. That's okay if you use the robotic, you use the automation. It is high quality, but it's still not perfect. Also, it's maybe 1%, 2%. จะต้องมีสักคนแหละซื้อของในแจ็คพอตที่ได้ของไม่ดี This is possible. That's not is possible. Okay. And QC use a lot of statistics to check. That's not. If you check your product, if the error is not or below the accepted, you have to send back to your process what happened in your process. That's right. You have to improve your process or not. And this is for the process development for the new product. And also in the academic, in the research, we have to get a new model. We would like to check a model and model development. Because if you get a model, you do the experiment, you do the process, and then you create a new model. And model this you justify or that. It's better because you can save process. Because you get a model. This model can justify your experiment. But mostly the research section in company, in university, the model development, and also the last one, you get the model, you have to validate your model. Validate your model. You have to validate before split off to you. Because the model validate means you have to check this. Can use or not? Perfect or not? You have to validate your model. Also, when you do the simulation, I'm not sure in this project based on only simulation. There are some, no, and this is on the experiment. But someone in mechanical and process system engineering do the model only. We apply some simulation to start for that. And before you use some program, you have to validate program before apply for the experiment. For that. And also, if you develop a new model, you have to validate. โอเคเนาะต้องไปที่นะครับแปลว่าอะไรไปที่เด็กประสบอะไรนะ validate you have to confirm your model can be used. Confirm by checking by do the experiment. Okay, this is why we have to perform the experiment. That's right. This is I show you. We have at least 3 techniques. At the top you 3 techniques that we research in the field of the science and engineering. We have the first is the only experiment. That's right, the experiment. And the second one, simulation. The simulation theory, experiment, and analysis. Okay, we have the experiment, simulation, and theoretical analysis. That's right. Theoretical analysis is you set up the equation, you solve by analytical technique, you analyze by theory only, or you use the simulation by numerical technique, or you combine between experiment and numerical technique. Like sometimes we call it empirical result. But for promote the solving problem, we have only three. Only experiment, only theory analysis, only simulation. But now they usually be merged between experiment and simulation. Because you do the simulation first to check the possible. Okay, if you check the possible, and then you try to do the experiment, you can save your money. That's why if you start experiment only, it's maybe you don't know what the parameter you should to do, what side of method, what side of experiment. It's maybe cost you money. That's why the simulation will help you to save money. And usually when you design some airplane, you design airplane, you start to build the airplane, but it's not work every again and again. That's right. This is money. It's cost. Okay, in the NASA, we have some apply the CFD. CFD means the program to analyze the fluid flow or chemical or something like this to check this is possible or not. That's right. The NASA build the simulator with the airplane and simulate the flow, that's right, of air around the airplane and check this is okay or not. And also when you do the scale up in chemical in maturity, you would like to scale up from lab to hand scale. The CFD also help that's right, to check first this is possible or not. Okay, if you check by simulation is possible, you can contract a new model, a new equipment. Is it will save your money, save time also, save time. But now you see when you study PhD, when you start master degree, some advice assign you to do both experiment and simulation. Why we did because you can save the money, you can reduce time for that. Okay. I do not talk all of this because this is like for the important thing. The second one is when you do the experiment, you have to do the literature. When you study PhD or master, the literature is very important because the literature we have some people research related to your topic or not. That's right. We have some data from the literature enough or not. That you have to find the data. You have to work the data. The data is enough. The data is accuracy or not. That's right. We found that accuracy and replicate. Like what is accuracy? What is common? What is accuracy? Accuracy, if you use the temperature sensor like thermometer, thermocouple to measure the temperature, you have to think what is the accuracy of the thermometer. Right. We have some accuracy, we have some precision, you know the precision, right? In Thai, I don't know what kind of ถูกต้องภาษาอังกฤษนะภาษาไทย accuracy and precision. Okay. When you do the experiment and you get the result, the result is accuracy on. It depends on your sensor, your equipment, right, for sensor. You have to check your sensor is accuracy and your data is accuracy. It's correct or not accuracy. It's correct or not. How to check is correct or not. That means you have a standard. That's right. You have to check with the standard. You have to check with the true value. If you measure the density of water, you have to know what is the density of water. And then you measure the density of water by your equipment. You have to check with the standard. You have to check with the data. This is accuracy, correct or not. But if you talk about the precision in Thai or the manual, precision means you measure one time, second time, third time, everything the same. You get the same answer. This is precision. But sometimes this answer is not correct. But still precision but low accuracy. It's possible. That's right. Precision means you repeat and then you get the same answer. This is precision. Okay, this is it have to consider with your when you use the balance. That's right. It's very carefully. You get the substance today and tomorrow. It may be added. It may be added. You have to check the precision and accuracy. It's very important, precision and accuracy. Precision and accuracy is very important when you do the experiment because it depends on equipment error and also human error. That's right. It's very important for you. And the second one, replicate. Replicate means the number of experiments that you repeat. When you do the experiment, how many one? Only one time. Because when you have to do the experiment, you have at least repeat your experiment. But I repeat means you do everything the same. The condition the same, the temperature the same, pressure the same, because you repeat the data. The replicate means the data that you repeat. One replicate, two replicate, three replicate. For my experiment, I do at least three replicate, three experiments. To check the data because experiment is statistic. Okay, this is the replicate. ภาษาไทยก็จำนวนคำศัพท์ This is the replicate of n นั่นเอง n is number of experiments. This is also the same meaning reproducibility. What is reproducibility? Reproducibility is the same meaning in precision. You repeat again and again, you get the same and the same answer. That means you can reproduce. You can repeat your data. But if you would like to check your thermometer and thermocouple, you check your temperature today and tomorrow is not the same. What happened? That means this sensor cannot reproduce. It's not physics. Because you check the system is the same, right? The system is the same, and then you check the temperature for your system today and tomorrow. If you get the same result, okay, your sensor is physics, and its accuracy or not, you have to check with the standard how to choose right accuracy. Like that. Okay. This is also mean that reproducibility. And important thing, like when you do the experiment, we talk about sensor and actuator. Could you give me example some sensor? I think you know sensor. I talked to you, thermometer is sensor. The sensor is the equipment to measure the property of the system. Measure the property of the system. You will measure density. You use the density equipment. You will temperature. You use thermometer. You try to check the concentration. You have to use TC, HPLC, for example, X-ray, something like that. This is sensor. Right? How about actuator? Actuator is equipment to control the system. Like for valve, we use the valve to open and close to control the flow. This is valve. You use the motor to control the system. For that, this is the actuator. It's also important when you do the experiment. Okay, I would like to, and then for the equipment, we have to equipment. This is input the reactor, right? Your material, your sensor, your actuator. When you do with chemical, I think or material and chemical. That's like you know about the chemical, like material about chemical. And we have to check your equipment can work well with chemical or not. If you graphite, okay, graphite is good or graphite is resist to the pollution, resist to chemical, but cannot resist the mechanical state. That's right. It's easy to break for graphite. They have to use the equipment with the material for the. You have to check the sign, what the sign that you need in your equipment. The temperature limit, your equipment. What is the temperature limit? This equipment can be used only about 10 degrees Celsius to 20 Celsius to 50 Celsius. It's higher than 50, cannot work because it degrades, for example. You have to check your material at that time. And pressure limit, chemical compatibility. Chemical compatibility, that means the equipment that can be work well in chemical. That means resist the chemical. No pollution. Pollution. This means that resist to pollution or resist to the degradation by chemical, and also sensor and actuator for this. This is the term that you have to consider before you do the experiment, before design the equipment. This is how we consider the equipment size. You have to check your sensor is in laboratory scale or industrial scale. That's right. This is also the cost. That's right. In industrial scale, it may be high cost compared to the large scale. How large the sample you have to decide of your experiment. How many replicates that we have to do. How many number of experiments. That's right. For this type, you know how many number of experiments. If you do the only two levels, the low and high. That's right. It may be center, it may be axial, or something like this. You can design your experiment based on how many data points. That's right. How many data points you need from the experiment. And the cost of raw material and reagent have to consider also. Will the sampling be reproducible enough if the equipment is very large? If your equipment is large, if you sampling your sample from the equipment, is it representative of your system or not? Because you do the reactor or your system is a vessel is about 5 liters. You sampling only 1 milliliter. This is enough representative of your system. You have to consider this. If you confirm this well mixed, for example, you have the reactor, you have to aggregation to mix and then mix well. Okay, you can say this is the well mix. You confirm this well mix or not? This well mix or not? You have to check this also. And the last one is very important: the safety of environmental issue. You have to consider this. The equipment talk about the deterioration, the degrade your equipment. How it's easy to degrade or is the reliability. Okay. The same. I think this is I show you some example. It would like to. You can contract your experimental design. You can design by yourself, and then you buy some material, and then you contract by yourself, or you buy from company. If you buy from company, for this case, we give you some example by this website for reactor. For reactor, this we have many kind of reactor with the site. For the site of reactor, we have the condition, pressure limit, temperature limit. For the top two, for this, give you some example. And also for the next, I give you some example of chemical compatibility. If you would like to know your reactor, your vessel, your tank, your tube, your pipe is compatible with the chemical or not, you can search from the website. It's maybe a lot because for this case, I give you some example of the stainless steel 316. I think you have one this for metallurgical engineering, metallurgical. Metal, okay. This is the stainless steel 316. If you would like to know stainless steel 316 can work well with any chemical or not, that's why you have to check this. If, for example, you search for coal hammer, like the chemical resistant, and found that if you excellent acetaldehyde, okay, don't worry, if your chemical is acetaldehyde, right? Stainless steel 316 is good, no resistance, no pollution, and work well with this chemical, for example. If your chemical is acetic acid is good, but doesn't mean good is some minor effect. It's slight pollution. It's maybe pollution. That's right. It's maybe pollution. When you do the experiment, you have to check your material. Your reactor is stainless steel 316. You have to check what chemical that you use. It's also pollution or not. Pollution or not. But in my lab scale, mostly it's glasses. I don't worry about glasses because glasses is quite strong receive to the chemical, but it has to develop the mechanical form, right? This list of chemical, right? Acrylonitrile, acetic acid, excellent. Alcohol, amyl alcohol, excellent. For example, right? For the ammonium chloride, needs some pollution. You have to check it with you use the chemical and equipment. You have to check if you use the thermometer. Okay, thermometer is the gas that is maybe received to the chemical. If you use the thermocouple is made from metal. Right, if you put the thermocouple to the chemical, you have to check if the thermocouple is replaced by this chemical or not. That's right. You have to check it. Very important thing you have to check before you do the experiment. And also material safety data sheet, you have to check. If you buy chemical, I think you can load the material safety data sheet MSDS. Right. But now when you buy chemical, and also you can find the MSDS from the website of that company. โอเคเขาไม่ให้เนาะแต่เราไปโหลดได้ You can download from the company that you buy from. And in material safety data sheet for all, right, they have some the name of chemical, the property of chemical, how to manage when it leaks, for that case, how to like first aid measurement, for example, for this case, measure accident. When it's accident, how to do that? When it leaks, how to handle and how to store your chemical. You can find from MSDA. When you buy chemical, if you would like to know how to manage it, if some chemical release to the environment, how to manage it. In MSDA talk to you. ในเว็บจะบอกไว้นะครับบอกไป how to manage นะครับ how to manage the property, the density, the molecular weight, the with property is found in material safety. Like for safety valve, it's very important in the laboratory. The safety valve, if you have some pressure release or some accident, if your system has a higher pressure, the pressure is higher than the limit. If the system has safety valve, the safety valve will release automatically. If you know the safety valve is a very high pressure, reactor will be exposed. You have to carefully if you do with the gas. It's very important. If you do with the gas and you have some reactor, some vessel, closed system. In closed system, the gas inside the gas, a lot of gas is high pressure. If the pressure is higher than limit or higher than the capacity of your equipment, your system, that's why it may be explosion. That's why it may be explosion based on the high pressure. But if you connect with the safety valve will be release the gas automatically. That's why it's helping you to save your equipment for that. And also, the safety valve can help to protect the environment also. If you release some toxic to the environment, but we have some the standard concentration. Okay, you have like 1 ppm parts per million. If you check your system is released higher than 1 ppm, this safety valve will be closed automatically. This means fail, open. If your system fail, it closed. That means you release higher than concentration than the standard. It failed, it closed your system. It fail open. If your system is higher than the standard or higher than the limit, it will be open to release some gas, for example. This is very important when you do experiment in the industry. Right? If you go to chemical engineering laboratory or equipment, we have some the safety one because we work with the gas. Like some alcohol. You have some alcohol, but the temperature increase, alcohol is also evaporate. You have some vapor of alcohol. If the vapor is very high and then higher than the limit, the pressure will get gas in the system. If the gas in the system is higher than the limit, the safety valve will be automatic open to release the gas from the system. This is very important for engineer sense engineer sense. Okay, the next one we talk about the sensor and actuator. The actuator. I think you do it when you found this out. You have the pump, you have the valve, you have the thermometer, you have the tube, you have the pipe, that's all. But actuator used to control or adjust the process variable. Right? We use the valve to adjust flow rate. The valve is not measure the flow rate. The valve is also adjust the flow. You can close, you can open, you can partially close, partially open. That's like to control the flow of the fluid. That's right. You use this one. Right. And also we use pump to transfer the fluid. That's right. We use pump to transfer the fluid, to control the fluid. Like you have use the compressor or blower to transfer the gas, for example. And we use thermostat, like for temperature control. Thermostat, usually you want water bath. Water bath has some temperature control, because inside water bath we have thermostat. That's why the thermostat control temperature, and then we release the water. That's why with thermostat, usually in water bath. And solenoid is also the same technique to control temperature, but use the magnetic. That's why in the electrical different technique. Usually you can find the solenoid in a very small equipment in computer, in chip. This is we show you the valve. I can get valve picture. Okay. That's right. VALV. Okay. Sorry, something wrong. Don't worry about it. We can find the mistake. VLVE. Okay. We forgot V. Okay. This VALVE. Forgot. What is the top? The top one. What kind of this valve? Butterfly valve. Good, yes, correct. We call this butterfly valve. What's like valve pieces? It's about butterfly valve. Yes, you translate to valve pieces. That's why when you open this valve, will be loaded. That's why it open and close. The water can flow. Right. This is the butterfly valve. And what is this? Gate valve. Gate means the door. You open the door, you close the door. The water can flow. You open that, you move this up, move this down. You can open and close the door. The water can flow. Like this. We call this gate valve because it looks like the door. Open the door and close the door. Like this is the gate valve. That's right. It's the same, but the direction of the flow is different. This direction is the same. The direction is not. So the flow in and flow out in different directions. But the gate valve is flow same. Because the gate valve is maybe high resistance. Right? Because reduce the resistance by the flow. Yeah. This is the valve we use to control the flow of the fluid. Right. This is pump. We use the pump to transport liquid. That's right. We use the pump to transport liquid. To transfer liquid from one point to another point. Usually we have two types of the pump. The top one is centrifugal pump. That's right. Centrifugal pump. You rotate the liquid inside and pour it out. And the second one we use the reciprocating pump. Reciprocating pump, or this is the example of peristaltic pump. In chemical or material, usually we use peristaltic pump. Why we use peristaltic pump? Why we usually for chemical, right? We use the pump to transport chemical. We use the peristaltic pump. Usually we have the tube, the plastic tube, right? ภาษาไทยว่าปั๊มรีดท่อรีดยา why we commonly use the ballistic pump in chemical industry compared to the cylindrical pump. We have an answer. We have answer. ต้องถามคนทำงานโรงงานหรือมั้งเนี่ย Why we commonly use the ballistic pump in chemical? Like in your lab, I think you use the ballistic pump compared to the dynamic pump or cylindrical pump. If you look at the cylindrical pump, the pump หอยโข่งก็เรียกว่า if the chemical flow into the pump contact with the propeller, contact with the pump equipment and flow out in the tube. But peristaltic pump, the chemical do not contact with the pump. It's only in the tube. That's right. It's only the tube. It do not contact each other. That's right. We have only the plastic tube or rubber tube. Inlet and outlet also flow in the tube. The chemical do not contact with another part, the side of the pump. This is safe, the pump. Because the chemical is maybe toxic to the pump. If you use this, the chemical will be contact with the propeller or impeller. Impeller will be depleted, will be corroded at that side. But for plastic pump, the chemical only flow in the tube. That's right. Flow in the same tube. You only compress, uncompress only. That's why we use the peristaltic pump in chemical industry. ถูกไหมเพราะมันไม่ได้เป็นคอนแทคกับอุปกรณ์อื่นใดเลยอยู่ในท่อ It also save your equipment. But the power is lower than the dynamic. That's right. The flow rate, the power is lower than for the capacity is maybe lower than the dynamic pump. For that. This is why we commonly use peristaltic pump in chemical industry. Also, when you do the laboratory, you need the pump. Usually, you use the peristaltic pump. If your chemical is quite hazardous or high corrosion to the equipment, that's important. You have to consider when you use the pump. I hope you will use the pump in your laboratory. Okay, this is why we use the peristaltic pump. บางคนก็เรียกว่าปั๊มรีดนะครับถ้าเป็นท่อยางก็ปั๊มรีดยางได้แต่เป็นจังหวะครับมันเป็น reciprocating pump นะครับ Okay, like this. This is your thermostat. Because we use the thermostat. This is thermostat, and we put this thermostat in water bath. That's right. The control system in water bath is thermostat. But for it is a small thermostat to control the temperature. When you use the water bath, I have to check. And you set up the temperature in water bath, and then you flow the water bath into your system. The temperature is not the same. Right? You have to calibrate first. If you control, you have some jacket put into the water bath at time, and then you would like to control temperature. You have to check the system. You set up the water bath 25 Celsius. In your system, it's not 25 Celsius because it has the heat transfer from water to the system. But you have to check, and you have sensor. You have what temperature from water bath, and you have the sensor in the system. We carefully to check. I do this. It's not the same. It's maybe about 1 degree Celsius, 0.5 degree Celsius different because the reactor or vessel that you put in the water, right? The water in water bath have to transfer the heat to the reactor, and then from reactor to the fluid inside the reactor. That's right. It has some thermal resistance based on reactor. For this case, you have to check. Okay, when you do that, you have to check. You have to thermometer or thermocouple put in the system and check with water bath. But sometimes at low temperature it's maybe the same. I'm not sure. It depends on the temperature also. At high it's maybe higher heat transfer. It maybe is equal. But when you do this, you have to check carefully. Right? You use the water bath to control temperature. But for example, you would like to control your system inside reactor at 25 Celsius. you set water bath 25 Celsius, but the temperature system is not exactly 25. You have to check by the sensor again. That's right. But sometimes you have to set about 25.5. Later it's maybe 25, for example. Right. For that, you have to carefully check this. I hope because some students, okay, you set in water bath, okay, this is 25. I found. That's right. This solenoid, as I usually is a compact equipment, compact คือกระทัดรัด That's right. It's small equipment like this. Is example of sensor. Right? This is the thermocouple. At the top we use thermocouple. If you use thermocouple, you have to check the thermocouple is compatible with chemical. If you use thermometer, I don't worry about that because thermometer can compare all chemical. These are from glass, but it is sensitive to mechanical strength. But thermocouple is made from metal. You have to check what kind of material in this thermocouple. Right, this is the couple. When you put the thermocouple in the chemical, you have to check that. That's right, for the compatibility with the chemical. This some pressure, right? Some pressure gauge. And also be carefully when you read the pressure gauge. When we use this data to find some property, to calculate some property, you necessary to check this is absolute pressure or not. Because this gauge pressure. If you would like to check the property of water, property of some chemical in the standard, it represents in terms of absolute pressure. When you calculate, you have to convert gauge pressure to absolute pressure. How to convert from gauge to absolute pressure. That's right. Because you use the sensor for pressure gauge pressure. Okay, if you do not use to calculate the other property, you don't worry about it. But if you use the steam table, the property of steam table, you have to convert from gauge to absolute. Because all data you found from the tablet is absolute pressure. Anyone can help me what is the absolute pressure calculation? Yes. PF Patrick, could you speak English? ห้ามคุยกันภาษาไทยไม่ใช่ Okay, that means if you read the pressure from equipment, you have get pressure past atmospheric pressure. That's atmospheric pressure. PATM, for example, you get the absolute, and then you can calculate some value. You open the steam table, you open some property. This is also very important. When you have to open some property, you will open property of the air. In the data, in the database, it represents in absolute pressure, like absolute pressure. But from the equipment, it gauge pressure. Okay, it's very, very important. You have to consider this. มีหลายเรื่องที่ต้องระวังนะครับเวลาทำอะไรต้องดูด้วยนะ Okay, this is some in advanced or tap analysis. That's right. I think in chemical and materials use this. This is use the X-ray. You can say X-ray not natural. X-ray. We use the X-ray. I think the material engineering study the material characterization. That's right. If you maybe study X-ray. Of the X-ray, single crystal X-ray. We use the X-ray to detect some composition or to check the metal, to check the pure or not pure, so that to check the composition of the element. And also I use the X-ray to check my chemical is pure or not. I have some check the crystal for that. You use the X-ray to calculate concentration. You can do that. Concentration. And also we did the HPLC. We use HPLC to determine concentration of solute in solvent. Concentration of solute, concentration of solid dissolved in solvent. And also this is the GC, for example. This is also the the sensor to calculate the concentration, to calculate the composition of the substance, right? Also, this is for analysis the particle size. We use equipment. In my lab, we have one equipment to measure the particle size in micron scale. In micron scale. In F and F11 is also in nano scale, and use the equipment. And this is for, I'm not sure what it is. BET, okay, for the particle porosity, surface analysis. Okay, for the question about the sensor and actuator, what we would to consider? We would consider the first, you have to check the property limit. With sensor, with thermometer, thermocouple, can measure 0 to 100 Celsius. You need to measure under 0, cannot have time. You have to consider the limit of the sensor. And the second one, the material property. Right? What kind of material? Okay, you use the thermometer in glass. Glass can receive the chemical effectively. If you use thermocouple, you have to check what kind of material for the thermocouple, and then you check the compatibility with chemical before you. And the last one, equipment, like limit to chemical, to temperature and pressure. Okay. Accuracy of your sensor. At the top, you accuracy. You use thermometer, you use thermocouple, you have pH meter. You need to have to check the accuracy. That means how to check, how to calibrate. That means when you use, you calibrate your equipment or not. The easy way to calibrate, you have to know the true property. That's right. You have the standard property. And then you check this equipment with the standard. Okay. This means the accuracy. They correct to the true one. The true one with accuracy. And the second one is reproducibility or precision. Reproducibility and precision. Because when you do the experiment, you need at least 3 replicates, right? At least 3 replicates. You repeat your experiment, and also you repeat your sensor. This sensor can mix again and again and get the same result or not. Right? This is the precision. This is the precision or reproducibility. Right? And the number 6, reliability. Reliability means how fast it deterioration. You use only 3 months, it declared or not availability. That's right. You can do this 1 year, 2 years. That's right. This is reliability. สามารถใช้ได้นานแค่ไหน before declared. And the last one that quite important also robustness. Robustness. If you read some paper report the technique. That's right. The technique that you use to measure the concentration, for example. Like for yesterday, I reviewed some paper. This paper proposed the technique to measure the concentration and measure the concentration of solute, also in the liquid and solid in the same system. He proposed the technique. And also this paper showed this technique accuracy on this technique precision on this technique robustness on. Robustness means the strong to the environment. If you check the environment, you check the condition, this equipment can be used. That's right. This is the robustness. If you use this sensor, okay, you use this environment and you change the environment for another system. This equipment stability. That's right. Not change. This is the robustness. Very important. For that, it is very important. This is the accuracy, reproducibility, reliability, and robustness. You have to consider. Not only for equipment, the technique also. When you propose a new technique, that's right, a new technique for do something, you have to confirm this is technique is accuracy or not. This technique is precision or not. This technique is robustness or not. Sometimes about everybody. Everything is about equipment. You have to check. Because I just read some paper, I review some paper. He talked about the new technique to determine the concentration of solute in liquid phase. But in liquid phase is still solid liquid. and solid also dissolve in liquid. It determines the concentration of solute in liquid phase. And this equipment also detects solid and detects solid in the same time. He forward and then he confirm accuracy, he confirmed the reproducibility, he confirmed the robustness, he tried to convert the element, try to check at high temperature, at low temperature, you try to check the effect of impeller, try to check the effect of PS. This equipment still works. Still works, get the same stuff. Okay. But this will important. การพูดมาแต่เช้าแล้วเนี่ย Okay. I think I talked to you already. We have two sensors, sensor 1 and sensor 2. I would like to know which sensor is high accuracy, which sensor is reproducibility. From this, we have sensor 1 to measure the temperature is 26.5, 6.2, 5.8, 5.5, average is 20. This is sensor 1. And sensor 2 is 26.5, 6.48, 6.5, 6.5, 5.2. Average is 26.5. And the true value is 26 degrees Celsius. You compare this sensor, which sensor is high accuracy, which sensor is high reproducibility, or both high and low. That's right. Which sensor is high accuracy from this? 1 or 2? You 2? 2? High accuracy? 2, right? What is the accuracy again? Accuracy means correct to the true value or the standard. But the true value is 26. But the sensor 2 is 26.5. The average value of the sensor is 26.5. But the true value is 26. Sensor 2 is low accuracy. That's why because you measure the temperature, the sensor 2 is 26.5. It deviates from the true value. Deviate from the true value. But sensor 1 is 26. Because the experiment we need average because you cannot do only one. There's some the average is 26 is correct. It's accuracy. But this accuracy low precision. Because you measure 5 times, you get the spectrum. It's quite different. 26.5, 26, 6.2, 5.8, 5.5 very spectrum. If you compare to this, you measure 5 times, 6.5, 6.48, 6.5, 6.5, about 0.2 deviation. That's right. You measure 5 times, you get the value is the same or similar or close to the same value. This is precision, high precision, but not correct. That's right. But sometimes you do the experiment like your balance. If you forgot to check your balance, you forgot. But you do 5 times, get the same result. That's correct. You have to minus the error. Right. You're not necessary to do again, but if you know the error, that's right. You can minus the error out. You get the correct one. But you have to calibrate that first. How much the error. That's right. Many times we can find that you use the balance, but not only for you. Many students use the same balance, but you need to measure the weight every one day. You have to check this day, tomorrow, next tomorrow. You get the same result, but you get the same. But the balance is not calibrated. That's why you have it is correct or not. If you would like to get good answer, you have to minus error. You have to calibrate and then what is error of it. You can do that. But you have to minus error. ต้องหาว่า error คือเท่าไหร่เพราะตาช่าง4 ตำแหน่งมันใช้หลายคนนะครับมันเกิด error ได้แต่ว่าต้องไปหา error ให้ได้ถ้าหาไม่ได้ก็ต้องไปทำใหม่ Okay, this is the accuracy. Because accuracy, you repeat again and again, you get the same result. That's right. For this case, you get the result is close to the same, but not correct. Low accuracy because the correct answer is the visit. You have the standard to compare. But this high accuracy but low precision. You repeat 5 times. The result is quite different, about 0.5. That's zero two for that. This is the accuracy and precision. Okay, I would like to break for 10 minutes.